Today we're going to be looking at section 8.2. It's on graphing simple rational functions. So our goal today is simply to do that, is to graph rational functions. And a rational function has this form, f of x equals p of x over q of x. Now when we talk about that, basically what they're going to say is that p of x and q of x are polynomials. So we're going to have a polynomial in the numerator and a polynomial in the denominator. So it could be a binomial, it could be a trinomial, it could be a monomial, whatever. But it's going to be polynomials. Now, the ones we look at today are going to be pretty simple. So when we talk about the parent function for a simple rational function, it's going to be this form, where we have the graph of a parent function is f of x equals 1 over x. And it's called a hyperbola. Okay, so these graphs are going to be hyperbolas. They consist of two symmetrical parts called branches. So and if you can see, I have the graph drawn here. It's also in your book if you want to look on page 558. But here are the two branches, and they are in quadrant 1 and in quadrant 3. The domain and range, we've talked a lot about the domain and range the last couple of weeks here, are all non-zero real numbers. So if we look at the graph, what value can you not have for x? 0. So the domain is all real numbers except 0, right? Right, you will never touch this vertical asymptote, okay? The vertical asymptote is the line x equals 0. It will never touch that. It's this dotted line. This dotted blue line is the vertical asymptote. It's a line that your graph will get infinitely close to, but it will never touch it or never cross it, okay? So we will never have 0 in our domain because that is the vertical asymptote. Now, when we talk about the range, what y values can we have? Everything again but 0, because we have a horizontal asymptote at the equation y equals 0. So the graph will get infinitely close to the horizontal asymptote, but it will never touch it. Okay? So any function of the form g of x equals a over x, where a is not 0, has the same asymptotes, the same domain, and the same range as our parent function. So if you see an equation in this form, right there, where you have a number over x, it's always going to be a graph that looks like this. Okay? These branches will be a little bit different, but the asymptotes will be the same, the domain will be the same, the range will be the same. Okay? They will all be the same. Does that make sense? All right, so let's look at example 1, and we will compare it with that graph. So if we graph this equation, y equals 4 over x. Well, let's make a table of values. So what number do you want to put in for x? 1. All right, let's put in 1. What do we get? 4. What other number do you want to put in? All right, let's try 2. What do we get? 2. And what other one? 4. Put in 4. What do we get? 1. Okay, so this is my one branch. Because I know that I'm going to have a horizontal asymptote here, right? And I will have a vertical asymptote there. They will never touch those. They will never cross those lines. So now we got to plot some points. All right, so we have 1, 4. We said we have 2, 2. And we have 4, 1. So there's that half of it. So now, what am I going to have to do for the other half? All right, let's plug in those negatives. So let's go -1, -2, and -4. So -1 would give us what? -4. -2 would give us, and -4 would give us -1, right? Exactly. Same thing in the other quadrant. Oop. Try that again. That's not much better. Oh well. So that's what our graph's going to look like. Now here it also says compare it to the graph, the parent function, right? So if this is the parent function, let's put that on there real quick. And you don't have to graph it. What's that? Yeah, but I like to always put it on this graph, and at least for the first one when we compare them. So if I would make the table of values, if I put 1 in here, what would I get? 1, right? That would be right here. What if I put in 2? I'd get a half, right? Which would be right here. And what if I put in negative, or what if I put in a half? I'd get 2, right? So this graph, our parent function, would look like this. And then that's going to be the same thing over here. So when we compare these two, the red one is the graph of our function, and the green one is the parent function. And you don't have to graph the parent function on your graph, but they're going to ask you to compare these today, and so you want to make sure that you know how to compare them. So what do you notice about the graph of the red and the green? What things are similar? They have the same what? Okay, the same general shape. Domain and range are going to be the same, and the what are going to be the same? Well, the quadrants, but also the asymptotes, right? So the asymptotes are going to be the same because it says so right here. Asymptotes, domain, and range will always be the same. Well, look at that. That's a very good question. The asymptotes will change, but it won't be in this form. We'll look at that as our next example. Okay. Now, how are they different? Well, we're going to say that this graph is further away from the axis as the other one. Okay. No, we're going to just say it's further away from the axis than the parent function. Okay, that's all you'd have to really say.
So if they're in the same graph,
Yeah, we're just going to plug in different values, which is going to make it. Now, if this was a number that was bigger, like let's say 10 instead of 4, if this number was y equals 10 over x, what do you think that would do to the graph? It'd be out even farther, right? What if this was like a half over x? It'd be closer, right? It'd be closer. So if this number is bigger than 1, it's going to be further away from the axes. And if it's smaller than 1, it's going to be closer to the axes. Okay. That will change something else. Right. Instead of, if it's negative, it'd be in the other quadrants, right? It'd be in quadrant 2 and quadrant 4. All right. The next thing we're going to talk about is graphing translations then of these simple rational functions. And this is where our domain and our range might change, our asymptotes might change, because we're shifting our graph one way or another, just like we shifted them the last couple days with our square root functions and our cube root functions. We're going to be shifting this right or left. Now, and I'm going to rewrite this because I don't like the way that it's on the notes here. A over x minus h plus k is the equation. Yep. Now, again, h is going to tell us it's a translation of which way? Left to right. Okay, left to right. That tells us how much we're moving the graph left to right. K tells us how much we're moving it which way? Up or down. Good. So h is left to right, k is up and down. So it says to graph these here, the instruction says draw the asymptotes x equals h and y equals k. Plot the points to the left and to the points to the right of the vertical asymptotes, and then draw the two branches of the hyperbola so that they pass through the points plotted. Okay. So essentially we're just making a table of values after we have our asymptotes in there. So if we go to example 2, and it says we're going to graph example 2. It says graph the function y equals negative 3 over x minus 1 plus 2. Now, generally, on these functions, where are the asymptotes? At what and what? X equals 0 and y equals 0, right? So in this one, if we're graphing this, where is the new asymptote? What about, let's go with the vertical one first. Which way is it going to move? To the right or the left? To the right, again. Right? Remember, this is a minus h, so we're moving it to the right, so the vertical asymptote is right there at x equals 1. Where is the horizontal asymptote? At what? What's the equation of it? Y equals 2. Because we're moving it up 2 So there are our asymptotes. Okay. Well, that's a good question. Will it change the domain and the range? Without even graphing this, you should know what the domain and range is, right? What can x not be? Can't be 1, right? Because that's our asymptote. So all real numbers except 1. How about our range? All real numbers except 2. So y cannot equal 2. So now to graph these, we're just going to plot some points. So let's make a table of values. What points? Let's graph the ones on the right first. What do I want to put in? 2. All right, let's put in 2. What's 2 minus 1? 1, negative 3 over 1. Okay, plus 2 is negative 1, right? So where does that go? At 1. Wait, what did we put in? We put in 2, sorry. Like we can't put in 1. So we put in 2, negative 1. So it's 2, negative 1. All right, so now what number should we put in? Let's put in 4. 4 is going to be easy. Why is 4 going to be easy? What's 4 minus 1? 3. So what's negative 3 divided by 3 is 1. 1 plus 2. Or sorry, negative 1. Negative 1 plus 2. 1. What did I put in? 4. I should write that down, 4. So 4, 1. And so here is this graph. Okay, notice what happened to it. Is that in the same spot we were before? No, because of this negative sign, right? Negative sign and that negative 3. Okay, now we have to also do the other branch, don't we? So what do we want to put in? All right, let's put in 0. You could. But put in 0, what do you got? Okay, so this is 0, it's negative 1, that's going to be 3. 3 plus 2 is what? 5. Okay, so we have 0 at 5. We're up there. And let's put in, then what's another easy one going to be? Negative 2. So negative 2 minus 1 is negative 3. Negative 3 divided by negative 3 is 1. 1 plus 2 is 3. And there's graph. Questions on that one? No? For these, the asymptotes, the asymptotes are gonna come from right here. So in this case, it would be x equals 1, and then in this case would be y equals 2. That's where we get those numbers from. Charlie. I'm not sure. I'd have to look at the graphing calculator to know that, if you can do them. So. You might have to, it might be the way you plug that into your calculator. Make sure you put parentheses around all of the stuff, because it might be doing the order of operations incorrectly on your calculator. That might be what is happening there. Yeah, and you're also probably going to need the x minus 1 in parentheses too. So it's not, otherwise it's probably taking negative 3 divided by x, and then going your minus 1 after that, right? So. All right, what I want you to do right now is try example, well, let's just do example 3. If you can do example 3, you can do all those other ones, right? So let's just do example 3. Everyone go ahead and try that. So at this point, go ahead and pause the video, and then you can hit play when you're ready. All right, so there is the graph for number 3. Notice again here, our vertical asymptote is at 3, and our horizontal asymptote is at 2. And then just make a table of values, plot in your points, and that's what your graph would look like. How many of you got that? questions? All right, then example 3, we're going to jump down to example 3. Yes. Oh, sorry, yep. Domain and range. So domain in this case is what? Right, all real numbers except x cannot equal 3. And the range in this case would be all real numbers except 2. Good, thank you. So y cannot equal 2. So it'd be all real numbers except 2. Good. Right, because it can't be your asymptotes. All right, so example 3, now we're going to graph this. And now notice in this one, instead of it just having x in the denominator, now we have a binomial in the denominator. So we're going to graph the rational function of the form, that should be of, not off, of the form y equals, and it should be ax plus b over cx plus d. Okay, now we're going to do the same thing. The vertical asymptote is going to be what? If we look at this example, first example A. What's your vertical asymptote? Nobody knows? What? Negative 3, right? Okay, it's got to be negative 3. What about our horizontal asymptote? This one's a little bit different. Right? Now, if we have two binomials, what we're going to do is we are going to take A divided by C. All right? That is going to give us our horizontal asymptote. So in this case, what would that be? 1 divided by 1, right? Because this is 1x over 1x, which is what? 1. So our horizontal asymptote is going to be 1. Because in this case, this is a 1, and this is a 1, right? So 1 divided by 1 is going to give us 1, so it's 1. So now let's plot some points. Put in negative 2. Well, we're going to get negative 2 minus 1 is negative 3. We'll do that, right? So I'm going to have negative 3 in the numerator, and I'm going to have 1 in the denominator, right? So what is that? Negative 3, correct? If I put in negative 2. So negative 2, I'm going to get negative 3. What if I put in negative 1? Negative 1 minus 1 is negative 2. And then negative 1 plus 3 is 2. So what's negative 2 divided by 2? Negative 1. So that's going to be negative 1, negative 1. So my graph will look like that. So now let's go to the other side. And let's plug in some points on the left. So let's put in negative 4. What's negative 4 minus 1? Negative 5. And then negative 4 plus 3, negative 1. So what's negative 5 divided by negative 1? 5. And now let's put in negative 5. So if we put in negative 5, we're going to get negative 6 over negative 2, right? Which is 3. So negative 5 is 1, 2, 3. And our graph's going to look like, well, sort of like that. Try to hit these points a little bit better. All right, so there's our graph. So in this case now, what's the domain? All real numbers except x is not equal to what? Negative 3. And it's all real numbers except for y is not equal to 1. Right?
Do we, when we write the domain and range, do we need to write all real, or can we just write like y not?
You should write all real numbers except for negative 3. Or, I mean, if you write that, that's fine, as long as you know what it means. But yes?
Are we going to have to graph inverses of these?
Probably not right now for sure. I don't think we're going to have to graph that, the inverse right now. But, all right, next one. Let's look at B. So, vertical asymptote. Raise your hand if you can tell me what it is. All right, what do you think? 1? Raise your hand if you think it's 1. Vertical. Raise your hand if you think it's -1. Why do you think it's -1? Why do you think it's 1? Because we have the negative x out here, right? So it's going to be where? -1. Because this would be, if it was just x, it would be at 1, right? But since we have that -1 in here, then it's gonna move it to the -1. Yep. So what is the horizontal gonna be? -3 divided by -1, which is 3. Okay. So now what are you gonna do? Plot them, right? Plug in some points. Let's put in. I'm gonna erase this so we got some room here. So let's start on this side. Let's go -2. So x, y. If I put in -2, what's -3 times -2? 6 plus 2, 8. And I put in -2 over negative, so that's -2. That's going to be what, 1? So that's 8. We put in -2, right? So that'd be, 2, yeah, 2 minus 1, right, which is 1. Right, so 8 over 1, so that should be 8. 6, 7, 8, up here somewhere. Now let's put in -3. What's -3 times -3? 9 plus 2, 11. And then if I put in -3, that's going to be a 3 minus 1, which is 2. So 11 halves, which is what? 5.5-ish. So our graph is actually going to look something like that, right? So let's try the other side, the right side branch. Let's put in 0. Oh, and I just drew right through my equation. So that's going to be 2 over -1, right? So what's 2 over -1? -2. And then let's put in 1. If I put in 1, that's going to give us, well, it's going to be -1 over -2. So that's going to be a half. There's your graph.
Is there any way on these to tell what you're asked for, or do you just like by looking, or how do you?
We'll look in a sec here. Domain. What's a domain? All real numbers except x is not what? -1. And y is not equal to 3. Questions on that? No? All right. Well, that's where we're going to stop for today. Your homework assignment is on page 561. Number 1, 3 through 6, 11 through 14, 19, 21, and then the 25 through 33 odds.